Every few million years, Earth faces a silent threat from the cosmos, one that has no warning sirens, no borders, and no mercy. Asteroid impacts are a real and powerful force that have shaped our planet's past and could very well shape its future. These cosmic collisions are not just the stuff of science fiction. They are a part of Earth's history, and understanding them is key to protecting our future. Let's begin with the past. About 66 million years ago, a massive asteroid roughly 10 kilometers wide slammed into what is now the Yucatan Peninsula in Mexico. The result was the Chicxulub crater and, more famously, the extinction of the dinosaurs. The impact unleashed energy equivalent to billions of atomic bombs, sending shockwaves around the globe, igniting wildfires, triggering tsunamis, and blocking sunlight for months. It was a turning point in Earth's biological history, wiping out nearly 75% of life and paving the way for mammals and eventually humans to rise. Fast forward to 1908. In a remote part of Siberia, near the Tunguska River, a mysterious explosion flattened over 800 square miles of forest. Trees were scorched and knocked down in a radial pattern, yet no impact crater was ever found. Scientists believe it was an airburst caused by a small asteroid or comet entering the atmosphere and exploding midair. The Tunguska event remains one of the most powerful natural explosions in recorded history, and it's a chilling reminder that even small objects can cause enormous devastation. And these aren't isolated incidents. Our planet bears countless scars from ancient impacts. Craters like Meteor Crater in Arizona or the Vredefort Crater in South Africa serve as evidence of the frequent visits Earth receives from space rocks. While many of these impacts were small, they prove that Earth is constantly being bombarded by cosmic debris, most of which burns up in the atmosphere, but not all. So how do we monitor what's out there? How do we detect these threats before they reach us? Around the globe, astronomers use powerful telescopes to scan the skies, tracking what are known as near-Earth objects, or NEOs. These are asteroids and comets that come within 45 million kilometers of Earth's orbit. With each night's observations, data is collected and used to determine their paths, sizes, and whether they pose a threat. Radar plays a critical role in refining the orbits of these objects. Once an asteroid is detected, radar allows scientists to create detailed models of its shape, spin, and trajectory. This data helps us predict where the asteroid will go next week, next year, or even 100 years from now. Time is our greatest advantage. And early detection is essential for any chance of preventing disaster. International cooperation is also vital. Agencies like NASA, the European Space Agency, and organizations around the world share their findings, combine data, and collaborate on planetary defense strategies. Cosmic threats don't respect borders, so protecting Earth requires a united global effort. But what happens if we actually find one heading our way? Could we stop it? That's where planetary defense comes in. Scientists have explored several deflection strategies, the most promising being kinetic impactors, essentially crashing a spacecraft into an asteroid to alter its course. Another concept is the gravity tractor, where a spacecraft flies alongside an asteroid for an extended period, using its own gravity to gradually pull the asteroid into a new trajectory. In 2022, humanity took a historic first step. NASA launched the DART mission, the Double Asteroid Redirection Test. Its goal was to deliberately crash into a small asteroid moon called Dimorphos to see if we could alter its orbit. And it worked. The impact shortened Dimorphos's orbit by several minutes, proving for the first time that asteroid deflection is not just theoretical, it's possible. But even with this breakthrough, one truth remains: we need time. If we detect an asteroid just days before impact, we have few options. But if we find it years or decades before, we could mount a mission, test strategies, and potentially save the planet. That's why continuous monitoring and research are so important. Looking to the future, the risks remain. Most threatening asteroids are large and rare. But smaller, city-killer-sized ones are more common and harder to detect. Our current efforts have discovered a majority of the largest in Eos, but thousands of smaller ones remain unidentified. These pose a real danger, especially since some may only be discovered days before a possible impact. To address this, future missions are already in motion. NASA's upcoming NEO-Surveyor Space Telescope will be dedicated to spotting hard-to-find asteroids, especially those that come from the direction of the Sun. Meanwhile, ESA's HERO mission will build on DART's success by closely studying the impact site and gathering data that could help fine-tune deflection methods. These missions mark the beginning of a new era in planetary protection. Advanced technologies may also play a role in the future. Concepts like laser ablation, asteroid net capture, or even using nuclear devices are being studied, though many come with technical and ethical concerns. What's clear is that humanity is taking the threat more seriously than ever before. So, where does that leave us? Despite our progress, we're still learning. Planetary defense is filled with uncertainties and known asteroids, complex trajectories, and limited resources. But what we do know is this: awareness, research, and preparation are our best tools. The threat may be distant, but it is real, and the more we invest in understanding it today, the safer we make tomorrow. As we gaze up at the stars, we must remember that our place in the universe is both beautiful and fragile. Earth has been hit before, could happen again, but now, for the first time in history, we might be able to do something about it. The challenge is not just scientific, it's global, generational, and it's one we can't afford to ignore. If you found this video insightful, make sure to like, subscribe, and leave a comment. What do you think? Is Earth truly prepared for the next big impact? And what kind of planetary defense would you put in place? Let's talk about it, because the conversation about cosmic threats is one we all need to have.